All you guys viewing out there, this video is a part of our tutorial for the Form 3 CXC syllabus. And today we will be focusing on the thermal physics. This is Bowe presenting to you, just so you know. Now, to start off thermal physics, the first thing we need to look at is heat. I'm sure most of you already have a general idea of what heat is. But how do you define it? Well, in order to understand how heat and also temperature are defined, let's take a quick look at these particles of a substance. These particles you see here of a substance are always in motion, and because they are always moving, they have kinetic energy, a term you should already be familiar with. They also have potential energy as they are separated. They are opposing the bonds trying to pull them back together. The total kinetic energy and potential energies of all the particles in a material is called its internal energy. As we move on to define heat and temperature, you should remember this concept. Okay, before we officially define heat, we should understand what temperature is. Most of you might think temperature is something like how hot or cold a material is. It's not necessarily wrong, but it's a bit vague. So they need a more specific definition. To make this definition, they use the concept of internal energy we just explained. Here's how it works. When a material is hot, its particles move around quite a bit, and so its particles have a high kinetic energy. Interesting. When the same material is cooled, the particles move around less, and the kinetic energy is decreased. This is a more accurate way of viewing temperature. Is often used by scientists, many of them. Alright, now that we have temperature, we can finally move on to heat. If we have two objects of different temperature in contact with each other, something happens, right? Well, one of the objects cools down, and its particles lose kinetic energy, while the other object warms up and gains a bit of particles from the kinetic energy. Now, since you should already know, the energy cannot be created or destroyed. This means at that point, energy must have been transferred. This energy that is transferred from one body to another as a result of a difference in temperature is called heat. Heat is also as well internal energy, we showed earlier, are often both referred to as thermal energy. There are two things you should note about heat. One is that heat is defined as the energy, right? This means that since the heat is an energy, it has the ability to work. Another point that heat always flows from warmer objects to cooler objects. When this happens, heat is transferred until the objects reach the same temperature. As we were explaining, you might have heard a lot about heat being transferred or flowing from one thing to another, right? But how exactly does this happen? Well, there are three methods in which heat can be transferred. Let's take a look at each of them. Now, the first method, heat transfer, we'll look at it, is thermal conduction, or for short, just conduction. Conduction is the movement of heat from one body to another that has a different temperature. So for example, if you touch a hot mug of tea, the heat from the mug will be transferred to your hand, which is why it feels hot. Another example is if you touch a cold glass, the heat is transferred from your hand. Notice, it's always heat that gets transferred. So whenever you touch something cold and you feel cold, the coldness is not what gets transferred, it's the heat. And never forget that the heat moves from hot to cold. By the way, not all the materials conduct heat the same way. Metals are the best thermal conductors. Non-metal solids and liquids are poor conductors, and gases are even worse. Materials that conduct heat poorly are called insulators. Because they often keep the heat in the object instead of letting it flow. Some examples commonly used of insulators are glass, water, plastics, wood, and rubber. Now, as we just explained, heat is only transferred by conduction when two objects have made contact. So only when they're touching, so to say. But what if the two objects aren't touching? Can heat still be transferred? The answer is yes. But though the different methods of heat transfer, and the way of transferring heat is called radiation. Let's first understanding radiation. You need to know a bit about electromagnetic waves. These waves can be traveled through any space, and they are waves that carry energy. Anything that absorbs these waves gets heated up. Because of this, they are often called thermal radiation. So, when the heat is transferred by radiation, the electromagnetic waves carry the energy from one object to another. And because electromagnetic waves can travel through anything, a form of matter isn't needed. Now, believe it or not, all objects give out thermal radiation. So, if you're sitting on a chair right now, that chair is giving out thermal radiation. Whatever device you're using to watch this video can give you out thermal radiation. Even you give thermal radiation. So when all objects, we mean all objects. But if so many objects give out thermal radiation, why is it that most of the time we can't see it? This is because most objects emit infrared waves, and these waves aren't visible to the human eye. However, when an object is heated up, the wavelengths become shorter, and if these wavelengths are short enough, they can become visible light. This is why an object starts to glow red when it gets very hot. Now, some substances are better at giving out thermal radiation than others. For example, a black frying pan cools down faster than a white one because it emits energy at a quicker rate. The same types of surfaces that are good at emitting energy are also good at absorbing energy. So black is a surface that not only gives out energy the fastest, but it also absorbs it just as quick. White and shiny surfaces are the worst absorbers because they reflect most of the thermal radiation away. This is why in many hot or sunny countries, uniforms are often white. They reflect most of the incoming radiation. The best and worst absorbers, emitters, and reflectors of energy can be seen in the diagram below. Now, we'll move on to each method of heat transfer. Like said, while we were explaining conduction, liquids and gases, also called fluids, suck at conducting heat. But since they are all free to circulate and move around, they can still carry thermal energy from one place to another. This process of heat transfer in liquids is called convection. Convection occurs when there is a difference in temperature, just like in conduction. Because the temperatures of the fluid are different, the density is also different. To make an understanding of this process of convection as clear as we can, we'll look at this in a real life example. Chances are that if you live in an island or have ever stayed by the beach, you've experienced sea breeze. But how does this breeze occur? Well, let's look at this diagram. This section here is drawn green in our land, and the section drawn in blue is our sea. During the daytime, the land is warmed up more quickly than the sea. Because of this, the air moves above the land gets warmer, and the air becomes warm. It also gets less dense and starts to rise up. As the air stays up, it eventually gets cooler. Once it gets cooler, it becomes more dense and starts to sink down. As you can see here, once the air sinks, it blows towards the land to replace any air going up. This cycle of air occurs. It's called a convection current, and this is how convection works. Alright guys, that's basically it for today's video. We should hope you were actually able to learn something from this little guide. It'll help out guys in the future And most important, thanks for watching. Click that subscribe button and the like button.